So, ladies and gentlemen, this is our last day to talk about um, the basics of energy sources. Today, we'll talk about the three fossil fuels that we're going to focus on. Fossil fuels were formed from the remains of living things that were fossilized over eons under the Earth's surface. Um, Coal was initially plant material in swamps that died and was buried underneath layers and layers of dirt. And with the heavy objects on top, the pressure and the time that passed, that plant material turned to coal. Coal goes through a series of stages. Um, it begins as a substance called peat, which then turns into lignite. Next, it turns into bituminous coal, and last, it turns into anthracite. So, from peat all the way through anthracite, um, those are all forms of coal. However, anthracite is considerably more energy dense than peat, but peat can certainly be burned. There's parts of the world where peat is burned directly. However, it's not mined or used necessarily as a source directly. Um, in the United States, this map shows the presence of the different types of coal that are available in the U.S. So it shows that the United States has an ample supply of coal remaining. Notice that there's quite a bit of it still in the Midwest. Coal is sandwiched inside the earth in seams. So you could think of it a little bit like icing between the layers of a cake. It's usually in seams that are flat or angled somewhat because of changes in topography. But depending upon exactly where that coal seam is located, that determines the extraction method or how the coal is mined. Coal surface mines used to be popular in Missouri. They're very unsightly and requires a whole lot of money to return the landscape to its original condition afterwards. So coal surface mines are not nearly as popular as they once were. They're really environmental nightmares. Shaft mines are the traditional deep mines where the coal seam is far, far underneath the Earth's surface. West Virginia has a lot of shaft mines because there are deep coal reserves under the state of West Virginia, and they're very large um, seams that make shaft mining worthwhile. Shaft mining at one point it was extremely dangerous. It remains dangerous, but it used to be very, very dangerous. So next we're going to shift to oil and natural gas. Oil and natural gas, like coal, are fossil fuels. The difference between oil and natural gas and coal is that oil and natural gas originate from zooplankton. So tiny plants and animals that lived in the ocean drop to the ocean floor. They're buried over time, and that time and pressure that pass turns those formerly living things into oil and natural gas deposits. Oil and natural gas typically exist together. So this is an example of oil and natural gas map in the United States. And in this graphic, it shows that when an oil field is located, then a natural gas field exists in the same place because typically natural gas will be in the area directly above oil. Notice that this shows that the oil and natural gas are sandwiched between something called impervious rock. An impervious rock is a rock that doesn't let anything pass through it. There are some oil extraction methods and natural gas extraction methods that are called enhanced methods that now involve how to extract oil and natural gas from rock that's porous. So this impervious rock notation here makes these really concentrated deposits possible. With enhanced oil and natural gas recovery, the oil and natural gas is sandwiched inside of these less impervious, more porous kinds of rocks. a very popular example of, and something you probably heard about, is something called shale gas extraction through fracking or hydraulic fracturing. That's where the shale is fractured or broken so that, as it shows in this picture, the gases that were kind of trapped inside can move freely once there's a sufficient pressure applied to push them out. It's a controversial process because it requires so much water and can there's some um, fear that there may be some instability of the ground that occurs around fracking, but that's something that you might be able to research. Again, when you do your report, you have to only include things that can be proven empirically. The last source that I'm going to mention here is something called the oil sands of Canada. That's another source that is starting to be mined because the oil prices have gotten high enough that it makes sense to try to extract the oil that is within the sandy soils. This might remind you a little bit of a coal strip mine. It does tremendous damage to the environment to extract from oil sands, but it's happening in some places in Canada right now. We're going to take a departure real quick and make sure that we're covering something called greenhouse gases. So greenhouse gases are not exclusively a byproduct of fossil fuels. Greenhouse gases can be emitted by many of the different sources of energy that you're going to be studying. However, the greenhouse gas emissions from fossil fuels are considerably higher than they are for some of the other fuel sources. So this graphic is intended to communicate the idea that greenhouse gases exist naturally in the Earth's atmosphere, and they are a good thing. If we did not have greenhouse gases within the blanket of the Earth's atmosphere would be way too cold. So greenhouse gases perform a very positive function to keep the Earth warm enough to sustain life and to keep water from freezing all the time. If water is frozen throughout a whole planet, that makes it not considered to be a habitable planet. However, the problem we're running into now is that we have more greenhouse gases than is optimal. The Earth had this beautiful balance of greenhouse gases for the majority of the geological time that we can gather data for, and now that balance has begun to shift. It's accelerating at a tremendous rate. The greenhouse gases are accumulating in the atmosphere. Now, it's unsettled science at this point whether or not climate change and global warming are occurring because of that, but it's impossible to contest the fact that greenhouse gases in the atmosphere are increasing at an accelerating rate. That is factual information. And you will find some information about greenhouse gases as you do your research. So that's why I wanted to do a little overview of it here. So the most common greenhouse gases are carbon dioxide, methane, and nitrous oxide. You may see water vapor pop up as a greenhouse gas. Water vapor does function as a greenhouse gas. However, water vapor is not part of any of the energy sources. So we're going to limit our discussion to these right now. So this graphic shows the relative effects of the different sources of greenhouse gases. Notice that the three that I mentioned are listed here. Here's carbon dioxide in green, methane is in this kind of pinkish red, and nitrous oxide is here in blue. There are other greenhouse gases that I did not mention that have a similar effect. However, their effect is smaller. It's a complex issue, however, because if equal amounts of carbon dioxide and methane were released into the atmosphere, the harmful effects of methane far outstretch the effects of that equivalent amount of carbon dioxide, because the greenhouse gas potency of methane is higher than carbon dioxide. Similarly, the greenhouse gas potency of nitrous oxide is even higher than methane or carbon dioxide. So it's not a linear effect. It's kind of interesting relationship. So you may encounter some information about those ideas. So your last thing you're going to be researching is fossil fuels, coal, oil, and natural gas. And once you finish with this little mini research that you're doing, then you'll be ready to choose one of these sources to do a deep dive report on, where you'll tell me all kinds of really, really important things about the issues surrounding that particular energy source. Do a good job. Good luck.